straight over to Ruth, who's going to look after you for the second half.
Yes, so good evening, everyone. Welcome to Skyscanner. Today I'm going to talk about my experience in bringing a simple machine learning model to advertising here in Skyscanner. I will share with you some of the experience that I, as a data science, had with an engineering team that never had a data scientist before. And then I will go to the steps of what was the approach that I took to train this model. But first, I tell you a little bit about data science at the Skyscanner. We have different data scientists working in different offices. We have London, Barcelona, Beijing, Edinburgh, Glasgow, and Singapore. These are not all Skyscanner offices, but here are the data scientists from Skyscanner. We are all in the same group, but basically we have two types of work that we call decision science and building data products. So decision science is more about doing studies and analysis with data that help us take better decisions. It can go, for example, for growth, for advertising, for products as well, but it's not part of the product itself, but more of an analysis, which is very valuable at the same time. And we have, but generally in decision science, you work alone. We have people that work in both, but we have also people working with building data products. That's basically building models, machine learning models or algorithms that will be part of a product with the intention of making the product smarter. And in this second part, you generally need to have cooperation with engineers, have some sort of collaboration there. So I start now with advertising. So this is a chart that I took from a report, very, very recent report. I actually showed this last year as well, but this now is an updated version of the revenue that online advertising brings to companies over different companies around the world. This is divided by mobile and not mobile online advertising. And what you can see right away is that it has been an ongoing increase since 2008. And especially after 2012, the increase for online advertising revenue coming from mobile is just going crazy. So one of the questions that companies that provide a service online have is how can we balance this potential opportunity to have revenue from online advertising with not losing the user, with keeping the trust of the user and engaging users at the same time. It's a tough decision. It's not easy to answer, but this is one of the questions that Skyscanner actually had to face, as well as many other companies. So one of the approach is actually, okay, we're going to put all our engineer efforts into building the product, the core product itself, to make the user happy. And let's just start hiring or making contracts with ad managers that already exist, so that we don't put efforts in building this product, these managers. So these are ad managers that are already very well known in the industry, that take care of delivering your ads, of making campaigns and putting your ads and making you have revenue. And generally they are efficient. The problem is that as you grow and scale up, you start having new needs. For example, what if you want to add something on the ad to make it more appealing for the user, also for the partner who is putting the ad in your site, and the manager that you have this contract doesn't provide. So what do? You also have some, you don't know what are the algorithms hidden in this ads manager. So if you want to modify something, you cannot, because it's basically a black box. And also, you have a lot of problems with data ownership. Generally, you don't have visibility of the performance of your ads unless you go to the user interface of the ads manager. So we're currently facing these problems. And one of the solutions to deal with these problems is actually to build our own manager from scratch. Not to compete specifically with these ad managers, external ad managers, but to grow and iterate in parallel. And in order that we can in order to deliver ads that can have a better return of investment to partners, and also that can be more appealing to the user. And with the opportunity to build like a new ads manager for Skyscanner also brings a lot of opportunity for data scientists, because advertising is one of those like areas that you can have a lot of data and a lot of interesting things to look at. So one of the tasks that I was assigned to start digging and look at is actually to look at building a click prediction model that basically will answer one question. Will this model, as simple as it is, be better than random? Meaning that when you have a space, you know, like an ad that you want to put, what if you have like 10 or 5 candidates to fill in this ad space? Generally, at the moment with a new ads manager, you would choose randomly, whatever one, and just put it there. Or you can have a little bit more of like a better judgment with a click prediction model and try to rank these ads based on the probability of being clicked. So here the test was to test whether it's better than random or not. Simple, right? So for that here, we can use like any type of language that we want to make these studies. But generally, most of us use Python. And we now have also like AWS services. We use S3 buckets in AWS to like store all this like big data that we have. We have Amazon Athena now that is sort of a query language that helps us like query all these data sets faster, and a system of batch systems that help us like schedule processes or jobs that will repeat the same type of analysis or training that you make on of different days or according to the schedule that you want. So this is the tools that I got. So how is that this advertising scenario or this ads manager scenario look like? So it looks like that. The model is in red. I made it red so it looks like nicer, but actually it's very tiny in comparison to the whole ad manager of what's going on. And this is already a simplified version. So I explain you a little bit how it is. So here, in this part of this service, this part of the advertising system, what it does is it takes care of like bringing all the campaigns and making sure that all the campaigns that Skyscanner has for a specific advertiser or partner that we call are entered correctly. You put all the creatives, like meaning the design of the ad that will appear, the targeting, how much they pay, which scheme they have. And generally, it's either someone in Skyscanner who enters that information or the partners themselves. That's the intention at least. Then you bring it here to the data set, to the database, and then you have this service that will take care of like bringing the ads to be displayed in the desktop or mobile. And at the moment, for that type of ad that I show you, this is pretty straightforward. It's just random. We randomly choose this, and then we, according to the placement and the target, and then we display it. Then we, at the same time, log information about the ads, for example, impressions, clicks, whether there was a price, whether it was visible, and we log that. So I use these logs in AWS to train my model. Yeah. So that's basically the scenario, and then I output a model that will be part of this selection of ads service. So that's the idea of how things would work. So at the beginning, right, I had to show them my idea of how this model would look like, and I wanted, okay, the idea that I had was, okay, we're going to have a batch system that we would train a model, would output the model. I have a service that will connect to the delivery service, that is that part that ranks the ads. And every time that I need an ad to be ranked, you just call my service, and I output to you and the predictions, the rankings. And the good thing about this type of simple architecture is that you can like retrain your model whatever you want. You can use all the technology you want. What matters is that at the end of the day, the delivery service will call the API service, and they don't really care. It's sort of like a black box for them. They don't really care what's going on or inside. I was even thinking about using TensorFlow, because although TensorFlow was used for neural networks, it also has some interesting functionalities for simple models like logistic regression or linear regression as well. So that was my idea, my expectation. But when I came with this argument to the engineering team, they were, of course, saying, hey, wait a second, we have a lot of things to do, and what matters here is just the proof of concept. We just want to know whether this model is going to be better than random. And building a service and implementing TensorFlow is just not possible at the moment. So let's stick with something simpler. You are going to output a model, and basically in a JSON file. So the model has to be simple enough to be output in a JSON file. We consume the file, implement the algorithm inside our service, which is like basically Node.js, and that's it. Yeah. So and we retrain this, and every time that the model is updated, that we read it again, implement the algorithm inside, and output. So that was my scenario. From the expectation to reality was for me a little bit of a change. So with these conditions, as well, there were other restrictions, like I thought about historical user data and different things about the device, but I was restricted basically to 10 features from like 20 that I had at the beginning. So what were how did I train the model? Let's look at it. So first, I went for reading the literature in advertising for click prediction models. I went for the easiest solution, that is basically just adopt a logistic regression. And I did compare with other algorithms like random forest and even neural networks using TensorFlow at the moment. But the improvement was not really different for these 10 features only that I had. So I used logistic regression, doing like different combinations of hyperparameters to try to find the best solution. Something that I learned myself is that, so coming from academia, before I was in academia, I would train a model, a logistic regression, using this, I don't know if whoever is familiar with Skylern, but you have this logistic regression function that takes the whole batch, the whole data, and just trains the model, and then you have the outputs. That happens when you have not such a big data set, right? So I had a lot of problems with data, with memory overload, and a lot of dimensionalities. So I ended up finding this other class that's called stochastic radius descent classifier. That basically the difference here is that instead of like taking the whole batch, the whole data set, it will start taking little by little, like in mini batches, the data set, and it will help you in not coming to, among other things, will help in not bringing you these problems of memory overload. So I took that. The challenge here is that you have to maybe sample a little bit your data to come up with the same results that you have in the other function. So that was very specific, but for me that was an interesting thing to learn. The other thing is like, okay, what to do with categorical values, right? The most common approach is to go with one-hot encoding. I did that. The problem is that all my 10 features basically were categorical, and you have this type of features like IDs, like advertiser IDs or creative IDs, which can get like huge, huge, huge. So I did run into problems with that. And when you use one-hot encoding, you have the problem that you have to bring a dictionary with you as well in the moment of doing the predictions and training and creating a dictionary when you train your model. Basically, you have to know all the values of your dictionary when you're training, in order for it to work in the testing as well. The advantages, of course, is that you can do inverse mapping, meaning once you have the trained model, you can see which encoding belongs to which variable. And also, it doesn't have problems of collisions, meaning that one vector is equivalent to one type of the one feature that you have. But there is this interesting thing also in the literature for advertising that is it's called the hashing trick. That basically is this function that maps your different arbitrary sizes of your categorical values to a fixed size of like sort of a vector of an array. And it helps you in just have, you don't need a dictionary in these cases, and it helps you to have like a set since the beginning size of array for you to use. The problem of is that is memory efficient. That's very good, but the problem is that there is no inverse mapping. Once that the model is trained, you cannot make this inverse mapping. You don't know which array belongs to which feature or categorical value, I'm saying. Sorry. And there's also the problem of hash collisions, that sometimes the same, different type of categorical values are assigned to the same encoding. So that's the problem, but eventually, in my case, and also in the literature, there's not a problem if you do measure. I mean, first you have to make sure that it's not a problem, and then if it's not, it can have like it doesn't damage the performance as much, and it's very good for memory. So with these conditions, I trained the model, and for the offline evaluation, the typical thing is to look at the OC, area under the curve, and I found an improvement, right? So this was the result. Yes, it's better than random. So basically, for those, of course, maybe super familiar with you, the line, the 45 degrees line is shows the random, and whatever you do above that, it means that you're doing better than random, and it was around 0.6. In the best of the cases, around 0.68 in the best of the cases. It was not much, but it showed an improvement. The challenge, of course, is to see and actually test if this works online as well. To communicate to people, though, it's very hard to use this type of metrics, either OC or log loss. You have to use something that they understand a little bit better. And for that, what I use is precision at one, that basically you group the ads according to the similar targets, and then you test your model with random. And if your model ranks the best performing ad first more times than random, then you can actually quantify the advantage of the model with your group. There are other tactics as well. There are people that do simulations or forecastings, but for me, this was the most straightforward way to show. So, how to carry this into production, right? So to carry this into production, I use the batch system. I update it, but actually I don't use one specific model, right? For each day, so this model is updated every day, but for each day, I train different combinations of hyperparameters and also different combinations of training data sets. There were times that I did with 7 days data set training, other times with 6 or 5. And sometimes it made a difference. In most of the cases, I did with 1 week data set. Some days I did with 2. And here it is, this is OC over time. This line that says best OC versus the worst OC shows you that there were some variances, some days more than others. And that if I wouldn't have done this, if I would have just go to one specific model that worked before, maybe I would have lost some performance with time. So, well, the lesson from this is that it's always good to try different, for me at least, for different models, and just pick the best one at the moment of delivering or of updating your or your algorithm. As a satisfying metric, like something that you also take into account when you have these different performances values from your algorithms, that was OC. I mean, I chose the best one based on OC, but also in precision at one. So it was a combination of both. And here you can see that how the precision at one differ from the random. And of course, I made sure that for each one of these groups, I had at least 5 candidates. And yeah, there's quite some difference. The last time that I checked, actually, it was 60% better than better than random. So that's basically how the model is updated every day. So the next question then is like, how is that you are going to be delivering your ad, right? Like, is it going to be only in like click based on in your click model? If that is the case, The problem with only basing your results, your ads in your click model, basically choosing the best ad to be like the ad that will give you more probability of being clicked, is that you will miss cases where, for example, ads were not shown enough, or ads that, because it's so dynamic, this system, right? Ads that are new. So because you don't know that, the algorithm will never choose them. So it's always good to not use the whole traffic in your click model, but also have leave a specific amount of your traffic for exploration, for trying specifically those ads that are not being ranked good enough or that didn't have enough impressions. And there are different approaches in the literature that you can see. You can change this percentage of traffic dynamically, set one specific. There are different interesting approaches that you can test. So basically, that's it of this project that I was involved. My learnings is that, okay, first is I learned with the engineer team that it's important to start lean to prove the value of your machine learning project. Especially if you come from academia, you tend to complicate things too much, maybe. So for engineering, it's very good to start lean first. And as a data scientist, it's always good to speak up front, right at the beginning, even if you start coding, what will be your needs, so that whatever expectation that you have, if that's not possible, if you're working with an engineering team, they would tell you right away, so you know and you're prepared. And if you have problems with dimensionality, to explore different ways of optimizing your resources, the ones that I use is use mini batching, the hashing trick. There are others as well. And so advertising systems are very dynamic, so be aware how you need to update your model. In my case, what I did, I tried different data sets, like different sampling methods, and also the size varied. So don't rely only on the winning one that won one time, because it cannot continue in the future. So that's it. Yeah, thank you very much.